In this video, we're continuing to write our list class, and in this one, we'll be writing the method that allows us to add a new value to the list. And after we do that, we'll be able to do some testing of our program. We'll be able to add some items and retrieve some items in a main program so that we can test everything that we've done so far out. So you probably remember that there's a couple different versions of the add method that's in the ArrayList class. There's one that just takes one parameter, the object to add, and it just adds it to kind of like the next available or open position. And if the ArrayList class isn't big enough, it resizes it automatically so that it has enough space to add that value. And so we're going to write a similar version in our program, but in our list class, remember we had to create it with a maximum size because we stored everything in an array as our underlying data type, and that has to have a maximum size. So we're going to assume that the client code, the main program or whatever's using our list class, doesn't intend to exceed that maximum size. If there isn't enough space for the new object, then we'll throw an array index out of bounds exception, just like we did in the get method if we tried to retrieve something that was out of bounds. So we're going to write the signature for our add method. We're going to add that into our implementation of the list type class. And remember, a signature just means the top line of code for the method where we specify all the information about it. So what kind of return value it's going to have. So for our add method, we're going to write it so that it's a void method. It doesn't return anything. We're going to call it add, and we want to allow us to add a new object, which I'll call value. I think that's going to be what, yeah, that's what I called it in the notes. That's good. And just like the get method, this one throws an array index out of bounds exception if they happen to exceed the array size that we have initialized. Alrighty, so now let's think about the implementation for the add method. And whenever I'm thinking about how to implement these methods, I always draw myself a little picture of like an example of array. So in this case, I drew one that has 10 different values in it, and it has a maximum size of 10. So that's one case we'll have to consider. What if the array already contains 10 items, and we're trying to add a new 11th item to that collection? Well, in our implementation, we want to throw the array index out of bounds exception in that case. If we're trying to add a new value and there's no space left, we want to throw that array index out of bounds because we don't know how to resize the array. When you get to future computer science classes, when you take the data structures course in a few semesters, you'll learn all about fancier data types that allow you to resize things. But for right now, we're sticking with the array because it's our old familiar friend, and we can't resize those. So if we get a request to add an 11th or 15th item to our list, we're just going to say, no, can't do. On the other hand, if the array has space in it, like let's say we only have 7 values in our collection, so we have 3 empty spaces, and somebody calls our add method, then we want to add that value to the next open space. So again, in this example, the actual size would be 7. And the space at index 7, 0, 1, 2, 3, 4, 5, 6, 7 is open. That's where we want to store the new data value that they're trying to add. So in our implementation, we're going to test for those 2 cases. We need to write an if statement again. So we're going to say if the, well, how could we tell which case we're in? First, let's think about like, how would we tell that we've reached the maximum number of items? So remember in that case, we had like some extra data values over here, and the actual size was 10 and the max size was 10. So if somebody's calling the add method and actual size is already equal to max size, that means that we've maxed out our array, we don't have any new space, we want to throw a new array index out of bounds exception in our code. No space left. Otherwise, we want to add the new value to the collection. So that was like the case where we had 7 values in here and we had these 3 blank spaces, and they were calling our add method with like the value 4, and we were trying to decide where should we put the value 4 in this array. So again, we could tell where to put it based on the actual size. That gives us the array index to add into, because 0, 1, 2, 3, 4, 5, 6, 7 is the first open space. So we want to say the array at index actual size equals, and then store the value that they pass in as the parameter. It's our new value we want to add to the list. So like if they were adding a 4, that would go in here. And then we need to update the actual size because now we have 8 items in the collection. 1, 2, 3, 4, 5, 6, 7, 8 values. Again, the next open space is the list at index 8. So we need to update the actual size. We're going to do that by adding 1 to it. Excellent. So we handled both cases for our adding method. I think I got everything in there. Yep. And at this point, we could write some main program stuff to test this out. Let me add some comments in here real quick. So this was the get method, the value at position index, the index of the item to return, value found at position index. Got all of my necessary comment fields in there. And remember that Java will, or IntelliJ will automatically fill in a lot of those pieces for you if you just wait until after your method's written. So this was the add a new value to the list. Value is the item to add. And then it throws an array index out of bounds exception. Super, so let's go into our main program, and we want to be able to test out some of these list type methods that we've created. So one thing we want to be able to do is make a new list type, instantiate the class, and I'm going to do that by calling the default constructor. And then let's write a loop that adds a few values to the collection. I equals 0, I is less than 5, I plus plus. Let's say we want to call my list dot add, and then I want to call with a object value like I. So I'm just going to add the values 0, 1, 2, 3, and 4 to the collection. And then suppose I write a separate loop for I equals 0, I is less than 5, I plus plus, and then I'm going to call the get method and print out the result. System.out.println mylist.get I. Again, we'd expect it to print 0, 1, 2, 3, 4. So let's go ahead and compile and see what happens. Okay, so we got our expected output. It stored the values 0 through 4, and then it went through my print loop to print everything out. Let's try putting something in here that'll force it to go out of bounds. Let's say we want to repeat this 12 times. We're thinking that should generate our exception. And sure enough, it tells us exception in thread main. Here's what we called when we were doing that. We were in the main program on line 11. That's the spot where we're adding values to the list. And we were in the add method on line 54. Line 54 is the one that throws the exception. So you can see the call stack trace is tracing through exactly where the exception's generated in our code. So it looks like both of the inbounds and out of bounds behaviors working. We could add in some more tests in our main program to try to test if like we're accessing an index that's too small, or we could set it up so we're storing strings or something else. But it looks like we're doing well so far. We've tested our add method, the get method, and our default constructor. Suppose we wanted to test the non-default constructor. We could do something like list type my list, whoops, capitalize, list type father list equals new list type, and pass in a non-default constructor parameter. So I set it up so it's 2, and then if we do calls to other list in here, other list, we would expect it to generate an exception because if we only have a maximum size of 2, we can't store 5 values. And again, it'll give us that same index out of bounds exception. We change this so that they're 2, then we'll be able to run it and the 0, 1 will print out. So now we've tested all the possible methods that we've written so far for the list type class.